Hello students, today we are going to discuss about the topic poison and antidote. What do you mean by poison? The poison may be defined as any harmful substances administered in whatever way, through by mouth or injection or inhalation or skin, and produce illness to our body or health. It will cause us sometimes disease or even death also. The self-medication is the major cause of drug poisoning. Self-medication is the major cause of drug poisoning. Poisons may be defined as the any substance administered in whatever way, by mouth or injection or inhalation or skin. It is produce illness to our health, our body, or disease or death also. The poisoning can be classified as three type: intentional poisoning, unintentional poisoning, and undetermined poisoning. What do you mean by intentional poisoning? A person taking or giving a substance with the intention of causing harm to self. With the intention. That's intentional poisoning. A person taking or giving a substance with the intention of causing harm to self. Example, that type of poisoning is suicide. What do you mean by unintentional poisoning? Unintentional poisoning, a person taking or giving a substance without knowing its toxic effect. Toxic effects. Example, accident. Accidental type of poisoning is the unintentional poisoning. That is two type of poisoning: intentional poisoning and unintentional poisoning. The third type of poisoning is undetermined poisoning. What do you mean by undetermined poisoning? Undetermined poisoning, when the distinction between the intentional and unintentional is not clear. The distinction between the intentional and unintentional is not clear. Example of such type of poisoning is the poisoning due to insecticide or pesticide. Poisoning due to insecticide or pesticide. That is three type of poisoning: intentional poisoning, unintentional poisoning, and undetermined poisoning. Next, also know about the heavy metal poisoning and cyanide poisoning. Heavy metal poisoning. This is poisoning occur due to intake of salt of arsenic, lead, mercury, iron, resulting into the toxic effect. This poisoning occur due to intake of salt of arsenic, lead, mercury, or iron, resulting into the toxic effect. The treatment: activated charcoal is given initially to the absorb heavy metal and followed by emetics to be eliminate any poison left in the stomach. This is the treatment of heavy metal poisoning. Activated charcoal is given initially to absorb heavy metal, followed by emetics to eliminate any poison left in the stomach. Next type of poisoning is the cyanide poisoning. Cyanide poisoning, this is poisoning may occur by inhalation of fumes of hydrocyanic acid, that is HCl. This poisoning may be occur due to the inhalation of inhale the fumes of hydrocyanic acid or ingestion of inorganic cyanide salt. Consumption of 300 mg of potassium cyanide may causes death. Consumption of 300 mg of potassium cyanide may causes death. The treatment: sodium thiosulfate and sodium nitrates injection as an antidote for cyanide poisoning. These are the two another type of poisoning: heavy metal poisoning and cyanide poisoning. The cyanide poisoning treatment is sodium nitrate and sodium thiosulfate injection as a given as antidote for cyanide poisoning. Next is signs and symptoms of poisoning. Signs and symptoms of poisoning: reduced breathing rate, nausea, vomiting, diarrhea, alteration in heart rate, muscle cramp, partial consciousness. These are the signs and symptoms of poisoning. Reduced breathing rate, nausea, vomiting, diarrhea, alteration in heart rate, muscle cramp, partial consciousness. Next, antidote. What do you mean by antidote? Antidote are the substances which react specifically with the ingested poison or toxic substance or with the potent drug in case of overdose. Antidote are the substances that react with the poison, ingested poison, that react with the ingested poison or toxic substance or with the potent drug in case of overdose. Classification of antidote. These are the three types of antidote is the first one. According to the mechanism of action, they are classified into three. First one, the physiological antidote. Second one, the chemical antidote. Third one is mechanical antidote. What the first one? Physical antidote. They are also known as a antagonist. They are also known as antagonist that produce the effect opposite to that of poison. Produce the effect opposite that of poison. That is physiological antidote. That is also known as an antagonist. Produce the effect opposite to that of poison. Example such type of physiological antidote is atropine and physostigmine are two antidote for each other. The atropine is antidote for physostigmine. The physostigmine is antidote for atropine. Next, the sodium nitrate in cyanide poisoning, that also physiological antidote. Sodium nitrate in cyanide poisoning. Next, chemical antidote. They react combining with the poison. They change its chemical nature by converting poison into inactive compound. Chemical antidote that react with the poison to get a change its chemical nature by converting the poison into inactive compound. Example of such type of chemical antidote: sodium thiosulfate convert toxic cyanide into non-toxic thiocyanate. Sodium thiosulfate convert toxic cyanide into non-toxic thiocyanate. EDTA as a chelating agent for heavy metal poisoning. EDTA as a chelating agent for heavy metal poisoning. Next, mechanical antidote. The mechanical antidote, they act by preventing the absorption of poison into the body or expel out poison by emesis. Mechanical antidote, they act by preventing the absorption of poison into our body and also or expel out the poison by emesis. These are mechanical antidote. Example, such type of antidote is activated charcoal. Activated charcoal. Activated charcoal absorb the poison to absorption into intestinal blast. Activated charcoal absorb the poison. That is mechanical antidote. These are the three type of antidote: physiological antidote, chemical antidote, and mechanical antidote. Example is very important. Next, in this chapter we have discussed three compounds: sodium thiosulfate, activated charcoal, and sodium nitrate. First, we have discussed sodium thiosulfate. Sodium thiosulfate molecular formula Na2S2O3.5H2O. Na2S2O3.5H2O. Next is synonym. They are also known as a hyposulfate or antichloride. Hyposulfate, sodium hyposulfite or antichloride. Next, preparation. Prepared by boiling sodium sulfate with a sulfur. Boiling sodium sulfate with a sulfur. That is Na2S2O3. That is sodium sulfate. Na2S2O3 plus sulfur gives sodium thiosulfate. Na2S2O3 is the reaction. Next, second preparation. by reaction of sodium hydroxide with sulfur. Sodium hydroxide 6NaOH react with 4 sulfur to get a sodium thiosulfate Na2SO3 plus sodium sulfate 2Na2S plus 3H2O is the reaction. These are the two preparation. By first one the prepared by boiling sodium sulfate with sulfur, second one sodium hydroxide with sulfur. Next, physical properties. Physical properties, it is a large prismatic crystalline powder. It is a large prismatic crystalline powder. Effervescence in dry air, practically soluble in water, insoluble in alcohol. Melting point 50 degrees Celsius. They are large prismatic crystalline powder. Effervescence in dry air, practically soluble in water, but insoluble in alcohol. Melting point 50 degrees Celsius. Next to chemical properties, decomposition of aqueous solution of sodium thiosulfate. Aqueous solution of sodium thiosulfate, first Na2S2O3, they decomposed into sodium sulfate Na2SO4, sodium sulfate Na2SO4 plus Na2S5. This Na2F5 again decomposed into further heating to get a sodium sulfate, that is Na2S plus precipitated sulfur 4S is the reaction. First sodium thiosulfate Na2S2O3 decomposed in aqueous solution to get a 3Na2SO4 plus Na2S5. This Na2S5 again decomposed into sodium sulfate Na2SO4 and precipitated sulfur 4S. These are the reaction. Next, chemical properties. Barium chloride react with sodium thiosulfate. We will get a white precipitate of barium thiosulfate. This is the reaction. Na2S2O3, that is sodium thiosulfate, react with barium chloride BaCl2. We will get white precipitate of Ba, barium thiosulfate BaS2O3 plus 2NaCl, sodium chloride. Next, assay. Sodium sulfate assay is based on the iodometric titration. The assay of sodium thiosulfate is based on the iodometric titration. Iodometric titrations. In this titration, the solution of sodium thiosulfate, 0.5 gram of sample dissolved in 20 ml of sodium, 20 ml of water, then titrated against 0.05 molar iodine solution using SARS solution as an indicator. SARS solution as an indicator. Excess of iodine react with the starch to get blue color. That is the end point. The assay of sodium thiosulfate is based upon the iodometric titration. In this titration, 0.5 gram of substance dissolved in 20 ml of water. 20 ml of water that titrated against the iodine solution, 0.05 molar iodine, when starch solution used as an indicator. At the end point, excess of iodine react with the starch to give a blue color. Iodometric reactions involve sodium thiosulfate to Na2S2O3 plus iodine to get a Na2S4O6 plus 2NaI. Equivalent factor, the iodine I2 is equivalent to 2 Na2S2O3, that is 1 ml of 0.05 molar iodine. 0.05 molar iodine equal to 0.02482 gram of sodium thiosulfate is the equivalent factor. Aromatic reactions involve the iron reacting with sodium thiosulfate. You will get a NO2S4O6 plus sodium added to NaI current factor 1 ml of 0.05 molar iodine, that equivalent to 0.02482 gram of sodium thiosulfate. Next, the mechanism of antidote. Their mechanism of action: when slow infusion of sodium thiosulfate through the blood. When slow infusion of sodium thiosulfate into blood, when cyanide ion present in our body, this cyanide ion react with the slow infusion of sodium thiosulfate. This sodium thiosulfate react with the cyanide in the blood. Such cyanide in the blood, they convert cyanide into thiocyanate. This is the mechanism. Thus, thiocyanate is excreted out from the body by kidney. Thiocyanate excreted out from the body by kidney. This is the mechanism of antidote. First, when slow infusion of sodium thiosulfate into blood, sodium thiosulfate react with the cyanide in the blood. This converts cyanide into thiocyanate. This thiocyanate excreted, FCN minus excreted out from the body by kidney. This is the reaction. Na2S2O3 plus active cyanide, that is CN minus, gives SCN minus to get an inactive thiocyanate plus Na2SO3, sodium sulfate. This SCN, inactive thiocyanate, excreted out from the body by kidney. Next, uses sodium thiosulfate used as an antidote in cyanide poisoning. Antidote in cyanide poisoning. Effective antidote in lead, mercury and iodine. Effective antidote in lead, mercury and iodine poisoning. Used as an antioxidant for solution containing iodide antioxidant. Standard titrant in iodometric analysis. Standard titrant in iodometric analysis. Used as an antidote in cyanide poisoning. Effective antidote in lead, mercury and iodine poisoning. Used as an antioxidant for solution containing iodide. Standard titrant in iodometric analysis. Their dose 0.3 to 1 gram. 0.3 to 1 gram of 10 ml administered by IM or intramuscular or intravenous route. Next compound, activated charcoal. It is a dark grey residue consist of carbon and any remaining ash obtained by removing water or other volatile constituent. It is a dark grey residue consisting of carbon and any remaining ash obtained by removing water and other volatile constituent. It is activated charcoal. Their preparation: burning of wood in absence of air. First, burning of wood in absence of air. Next, the residue is obtained consists of pure carbon. Residue is obtained consists of pure carbon. Next, the activation of charcoal. When activation of absorptive power of charcoal increased by treating it with it's not power, it's power. Absorptive power of charcoal is increased by treating with various substances such as steam, carbon dioxide, ZnCl2 at a high temperature. ZnCl2 at a high temperature 500 to 1000 degrees Celsius. Charcoal activation result increase in total surface area. Charcoal activation result in increase in total surface area. First, the burning of wood in absence of fire. The residue obtained consists of pure carbon. Then activation of charcoal. The absorptive power of charcoal increased by treating it with various substances such as steam, carbon monoxide, zinc chloride. Carbon oxide, zinc chloride at a high temperature 500 to 1000 degrees Celsius. The charcoal activation result in increase in total surface area. Their properties: It is a fine black odorless powder. It is insoluble in water. It is a fine black odorless and also tasteless powder. It is insoluble in water and other organic solvent. Its properties: fine black odorless tasteless powder. It is insoluble in water and other organic solvent. Next uses: it is used as an emergency antidote in many forms of poisoning. It is used as an emergency antidote. It is used as a protective and adsorbent. Due to high surface area, it is used as a filter aid. And it is used as a disinfectant in wound, constituent in for gunpowder, and used in overdose of aspirin. These are the uses. It is used in overdose of aspirin, constituent for gunpowder, disinfectant in wound, used as a filter aid, used as a protective and adsorbent. It is used as an emergency antidote in many forms of poisoning. Next compound, sodium nitrite, that is NaNO2. It is a nitrous sodium salt of nitrous acid, also known as synonym nitrous acid sodium salt of nitrous acid, or ettinitrate. Next is the preparation. It is prepared by heating sodium nitrate, that is NaNO3. 2 NaNO3 heating to get a sodium nitrite, 2 NaNO2 plus O2. It is prepared by heating sodium nitrate 2 NaNO3 gives 2 NaNO2, that is sodium nitrite plus O2. Second preparation, it is prepared by heating sodium nitrate with lead. NaNO3 plus lead gives NaNO2 plus lead oxide, PbO. It is the reaction. NaNO3 plus Pb, lead, gives NaNO2, sodium nitrate, plus lead oxide, PbO. Next, properties. It is yellow white crystalline powder, freely soluble in water, less soluble in alcohol. It is odorless. On exposure to air, readily form sodium nitrate. On exposure to air, it readily forms sodium nitrate, that is NaNO3. It is the properties. Next, mechanism of antidote action. When injection of sodium nitrate, NaNO2, causes oxidation of ferrous ion of haemoglobin, that is Fe2+, a ferrous ion of haemoglobin into ferric ion of methemoglobin. When injection of sodium nitrate, NaNO2, that causes oxidation of ferrous ion of haemoglobin into ferric ion of methemoglobin. This methemoglobin they combines with the serum cyanide and to produce cyanomethemoglobin, cyanomethemoglobin. It will cause the prevention of harmful cyanide. Cn minus ion. It is the mechanism of antidote action. It is the reaction. It is the ferrous salt of hemoglobin, Fe2 plus salt of hemoglobin, in presence of NaNO2. It will produce methemoglobin. That is methemoglobin. There oxidize Fe2 plus into ferric ion, Fe3 plus. This methemoglobin react with the serum containing cyanide ion will get a cyanomethemoglobin, that is a inactive cyanide ion. It is the reaction. Uses: it is used as an antidote in cyanide poisoning. It is also a vasodilator action due to the nitrate ion relax the smooth muscle of blood vessel. It have vasodilator action due to the presence of nitrate ion that will causes the relax the smooth muscle of blood vessel. And also anti-rust solution to prevent the rusting of surgical instrument, that is anti-rust solution. And their dose, there are 10 to 15 ml of 3% solution. 10 to 15 ml of 3% solution It is used as IV. Is the uses. So as antidote in cyanide poisoning, also used as a vasodilator action due to nitrite ion relax the smooth muscle of blood vessel, and it is used in anti-rust solution to prevent the rusting of surgical instrument. These are the three drugs. Sodium thiosulfate, very important, and activated charcoal, and third one sodium nitrate, discussed in this chapter. Okay, thank you all.